Okay. So today we are going to start off with the concept of rotation. A lot of people get confused by the difference between the circular motion and a rotational motion. But there's a very small difference, and you can understand it by this fact that imagine there are cars moving in a circle on a road like this. So if you are taking a turn with your car in a circular road, that type of a motion is what do we call as a circular motion. But when I'm talking about rotational motion, for that you require an axis. On an axis your body is rotating. That is what a rotational motion is all about. Okay, now today we will actually be starting off with the concept of rotation, not the circular motion. Circular motion is a different topic, rotation is a different topic. Earth's rotation is one of a very good example for that. Now to understand it, we can make a very basic thing out of it, that is, just like we actually were having velocity, then displacement, acceleration, time, all of these things are over here in the rotational motion as well. But it's very simple. How will we actually understand it? Have a look. Imagine there is a setup when you actually lift a dumbbell. So of course your hand is kind of straight, then you actually turn your hand like this. So in this scenario, your hand is not going anywhere else, your hand is just rotating. So you can say your body is, or your hand is rotating like this via a particular angle. This angle can be anything, it can be 90 degree, 30 degree, 60 degree, whatever. But my point is that your hand is rotating while this process. So you are not covering displacement, you are actually covering from here to here, you are covering angular displacement in this process. Okay, now this is the first thing. So what can we say in this situation? First of all, that we are not covering displacement, we are covering angular displacement. Now the second thing, displacement converted into theta, angular displacement. Now how quickly you are actually turning your hand. Yeah, if you actually take a dumbbell and you move your hands very slow, then you are doing it like, of course the velocity, the kind of velocity is slow. But if you rotate your hands very quickly, then your angular velocity, not the velocity, your angular velocity is very fast. So now the velocity is getting converted into angular velocity represented by a symbol omega, which is actually telling you how fast a body is rotating or how slow a body is rotating. Just like in a linear motion, we explain everything by a concept of velocity. In a rotational motion, we explain everything by a concept of angular velocity. That's it. Okay. Very simple, very easy. Now, all the other things are also very simple. Acceleration is all about change in velocity with respect to time. The rate of change of velocity is what do we call as acceleration. Exactly in the same way, the rate of change of angular velocity is what do we call as angular acceleration. That's it. This is the only thing. So what can we say? Till now, whatever we have learned, we can apply everything. That velocity getting converted into angular velocity because we are rotating now. Displacement getting converted into theta, that is angular displacement. Acceleration getting converted into angular acceleration, and time remains time. Time is a scalar quantity, it's not a vector quantity. That's why it will not change at all. Okay. Now this thing will continue with a slight more difference. And what is that? Now, first of all, when we actually complete a one full circle, everyone is aware of this fact that when we complete a full circle, how much angle are we covering? We are covering an angle of 360 degree. Basically, the theta is equals to 360 degree, which can be written as 2 pi in radians. A lot of people get confused. Keep it in mind, this just like we actually measure distance in meters, kilometers, centimeter, millimeter. There are a lot of different units to measure distance. There are different units to measure angle as well. Exactly in the same way, degree is one of the angle, sorry, one of the units, and radians is actually one of the units. And the SI unit for calculating the angle is of course radians. So this is SI unit as well. So whenever you deal with it, try to take radians. Now, what can we say? That just if I want to basically make the formula for velocity, velocity is equals to displacement upon time. So can I make a formula for angular velocity as well? Angular velocity will be equals to angular displacement by time. Exactly. This is what I will use. So this is what I will use for this situation as well, that how much theta or how much angle am I covering? I am covering an angle of 2 pi. And similarly, how much time am I taking to convert that? So how much time? It is 1 by t, that is the time period. This time is all about the time taken by the body to complete a one full circle. Now we can move it, explain it in a different way as well. As we all know that time is all about 1 by frequency. The relationship between time and frequency is this: time and frequency are inversely proportional. So what can we do? We can also write this equation as 2 pi into frequency. Either you can use the symbol or you can write f. That is 1 by time period. This thing, 1 by time period, is all about frequency. So everything which I have written over here, a lot of people will try to remember it. I will recommend you not to remember it. You can understand this, that velocity is displacement by time. Then angular velocity is angular displacement by time. Acceleration is velocity by time. So angular acceleration is angular velocity by time. And so on and on, you can remember all of them. Understanding it is very important. Now, the three equations of motion as well. So we are very familiar with the three equations of motion. V is equals to u plus at, s is equals to ut plus half at square, v square minus u square is equals to 2as. So what can we say in this situation? That we can convert these three equations into rotational version as well. That is the final angular velocity, initial angular velocity plus alpha into t. Okay. Then the displacement covered by the body, but angular displacement, then angular velocity, angular acceleration, angular acceleration, angular displacement, so on and on. Exactly the three equations can be converted like this. But now coming to the questions, what type of questions will you actually see? The questions will be very easy, but sometimes you will actually see a question like this, where it is written that the angular speed of a motor wheel is increased from 1200 rpm to 3120 rpm. Now, a lot of people will think that this is the value of omega. Yeah, they will think that, oh, this is omega angular velocity, but no. Keep it in mind, this RPM, the letter RPM written over here means the rotations per minute. That is, the RPM is rotations per minute. And now you have to convert RPM into RPS, that is the rotations per second. And exactly how many rotations you cover in a single second is what do we call as frequency. Very important. Okay. So these things over here are not the angular velocity, they are angular frequency kind of a thing. So it is written in RPM divided by 60, and you will get the value of frequency in terms of RPS. Now, once you get the value of frequency in RPS, you can very well easily use it to calculate the value of angular velocity like this. Okay. So angular velocity is equals to 2 pi frequency. We calculated frequency and we are putting it to calculate the answer. Fine. Fine. We are done with this. Now we can also make new formulas which are also very, very important. Now, this will be slightly different. Now, first of all, you should all be aware of this formula, that is angle is equals to arc by radius. That is, if I take a circle and if I'm talking about a certain angle in a circle, so this particular thing is the angle. Of course, this is radius, but the arc length from here to here, this is L. And there is a formula which is very important, that theta is equals to arc by radius. Very important. Why am I using it? Because using this, you can also say L is equals to R into theta. And now you can differentiate both the sides. That is, you can do dl by dt is equals to R into d theta by dt. Very important. Basically, you are differentiating on both the sides. And now distance by time or displacement by time is velocity, and angular displacement by time is angular velocity. From this, we actually come up with a formula V is equals to R omega. Now, individually, this formula is not very important, which means you will not see a lot of questions specifically on this formula, but there are a lot of different topics on which this formula is actually integrated. So indirectly, this formula is very important. Similarly, I can also say that once I get the value of V is equals to R omega, if I further differentiate it again, then I will see that velocity by time is acceleration, angular velocity by time is equals to angular acceleration. That's it. Very simple. So this formula is again very important. So now the next topic is all about torque. It's very simple. Now the next topic is all about torque. It's very simple. Yeah. So what can we understand about torque? Imagine I have a wrench. I basically have to open a nut. Why do we have a wrench with a handle? Why can't we just open it with fingers? What's the main reason of this handle? The reason is because you are not trying to like push this particular nut over here. No, you are trying to rotate it. Now, exactly this rotating force is what we call as torque. So we can define torque as the rotational force. Whenever you apply the rotational force on anything, that's torque. Imagine you are actually taking a gate and you are trying to push it. But when you actually push it, what happens to the gate? Is it actually moving away? No, it is actually rotating by this particular axis over here. Okay, very important. This is the first thing. So what is the whole meaning of this torque? Torque is all about how much force you apply from the length of the rotating axis. This is very important that here. So how much force you are actually applying from the length of the rotating axis. Now, what does that mean? Now, you have a particular nut over here and you are trying to open it. So what will you prefer? Will you prefer a longer length, or will you prefer a shorter wrench over there? Of course, you will prefer a longer one, but how will you do it? Now see, because the length is actually bigger, then automatically torque also becomes bigger, because as we can see that torque, this is the symbol for torque, it is directly proportional to length. So bigger the length, then bigger the value of torque, and smaller the length, smaller the value of torque. We can actually take one more example over here. How? Imagine this gate only, and you are trying to open or close this gate. Because you know this is the axis. Now, if you will be very close to this axis, let's say you are opening the gate by pushing this particular area, I think it will be comparatively tough as compared to a position if you are pushing from here. So it becomes very easy if you are very much far away from the axis of rotation. So farther you are, then like easier it becomes to open or close a gate. Okay, this is why I'm saying that in both the situations, maybe your force is actually same, but because the length is varying, the value of torque is varying, which is the rotational force. Very important. Okay. So keep it in mind, torque is all about a rotational force, and we can also call it the moment of force. Fine. Now, let's take one more example of torque where we actually see the directions for torque as well. What does that mean? We all have seen this balance way, of course. Now, this is the axis of rotation. Now, this is where this particular rod will actually rotate. Now, if you will put weight on this side of the scale, this will try to rotate the whole thing like this. And that's why I'm saying this is the anti-clockwise torque. Okay. What can we say? This is the weight you are putting over here is causing an anti-clockwise torque. Whereas if you will put whatever weight over here, that will cause a clockwise torque. Okay. Now, in both the situations, let's say if we say that the torque here and torque here, or basically the body is not going down, up, body is not changing its position, then we can say that clockwise torque is actually equals to the anti-clockwise torque. It is exactly like the method when we say the force acting left and right of a body are actually equal to one another. It's like just like a balanced force. We can also say balanced torque. Yeah. So imagine a situation like this. I have a weighing scale. So at a distance R1, I have a 10 kg body. At a distance R2, I have a 20 kg body. So I will calculate torque here as well, torque here as well, and I will put them equal to one another. We'll get the answer. Very simple. But there are few questions in which you actually will get confused. Reason? Imagine a situation like this, yeah, where the force is actually acting like this. What do we call? So this is the distance from the axis of rotation and the force is acting like this. Now you can actually see that this force is actually having a theta angle with the distance. Now you can make two components. The component with the theta is the cos component and component opposite to the theta is the sine component. Now this cos component has no use in rotating a body. It's just like if you take a gate and you start like pulling it rather than opening it, you are just pulling it from the hinges. So it will just get out of that particular thing. Yes or no? So the cos component is completely useless right now for creating the torque. Only the sine component is useful, or I can say the perpendicular force is useful. And to make it very simple, we can say that torque is equals to the force into the perpendicular distance from the axis of rotation. If this is the axis of rotation, only and only the perpendicular distance is responsible, nothing else. Okay. Now, how to find the perpendicular distance? So you can imagine like this, that if this is the point or the axis of rotation, and if this is the force, just extend it in both the directions. Extend it behind, extend it further, you will find a perpendicular distance. Now this is a force, and what can we say? That take a perpendicular, like extend it further, extend it back, and take a distance like this, and this will be the perpendicular distance. That's it. That's it. Okay. So simply extend the force in both the directions. You will understand where the perpendicular distance is. For example, let's have a look on this question. It says a force of 40 Newton acts on the point B at the end of a L-shaped object as shown in figure. The angle theta that will produce the maximum moment of force about the point A is given by. So we have to calculate the value of theta. So first of all, we need to know the perpendicular distance. For that, take your force, extend it behind, extend it further in the forward direction as well. And now, of course, there will be one point where you can say, okay, this particular point or this particular line is the perpendicular distance. Okay. So we got the perpendicular distance. After that, solving question is not a big deal, but this is how you deal with the perpendicular distance. That's it. Now, there is a very important question in the NCERT as well, as you can see this one. Now, why am I saying it? I will just give you the brief of how to do this problem. Now, this is a whole scale, this is the center point of this. So you can say this is the axis of rotation as well. Now there is a knife which I'm placing over here, which will give a reaction force in the upward direction. Another knife in the upward direction. Now, and there is a weight on the left side, which will of course cause a force in the downwards direction. Now this reaction force, what kind of torque will it apply? The reaction force will cause a torque in the anti-clockwise direction, whereas this one will cause a torque in clockwise direction, and similarly this will also cause a torque in the anti-clockwise direction. This is how it will be done. Again, put the clockwise, anti-clockwise equal to one another, you will be done with it. Okay. Questions are very easy. It's like this. Yeah. So if this is the axis of rotation, so this will cause clockwise. If this is the axis of rotation, this will cause anti-clockwise. If this is the axis of rotation, this will cause anti-clockwise, like this. That's it. Now, so there are a lot of things which we have done, but before that, we have to move to one more thing, and that is what do we call as the angular momentum. Okay, now if we want to talk about the concept of angular momentum. So what is happening? Force is getting converted into the rotational form, which is the torque. And now if I'm calculating the value of torque, torque is equals to the cross product of R and F. Yeah, that is, take the perpendicular distance, force, and just cross product them, and you will get a torque. This is the formula. Now to make the formula for angular momentum. First of all, what do you have to do? You have to take momentum, take the perpendicular distance, just do the cross product between them, and you will get the angular momentum. Exactly the same thing. So what is happening? To calculate the value of what? Angular momentum, you require the perpendicular distance from the axis of rotation. So you can also write momentum into distance, or actual formula is simply the cross product of R and F. That's it. Now, the simple thing is R cross P like this. So take the perpendicular distance, multiply it with what? Momentum, you will get your answer. Very simple, very easy. Now, as this is easy, there are other things which are even easier than that. That is, someone, if they ask you how to calculate the work done by a torque, or if they ask you power delivered by a torque, it is even easier. Why? As we know that the formula for power and work in the linear case is very easy for us. That is, power is actually the product of force and velocity. I think you know this formula. If you don't, let me tell you. The formula is very simple, that power is equals to work done by time, and work can be written as force into displacement. So displacement by time is equals to velocity. So power can be written as force into velocity. Now, the power is equals to force into velocity, and work is equals to force into displacement. How are we converting force into the rotational form? That is the torque. How are we converting velocity into the angular form? That is angular velocity. Force into angular form, that is torque, and displacement into angular form, that is theta. So it's very simple to remember these formulas. That is, just simply multiply the same things which you are doing above as well. So this is the linear form. What can we say? This is the linear version of the formula, and this is the rotational version of the formula. That's it. Okay. So just convert it, you will get your answer. Now these things are very easy, very simple. Everything goes on very easy. Yeah. But the important part comes when I have the concept of mass. So as we all have learned the first law of motion, that is, every body in motion will continue to be in motion, and every body in what can we say, at rest will continue to be at rest. That is the law of inertia. Now exactly that mass is converted into the moment of inertia. Now what is that? We'll understand it. Have a look how. So to do it, it's very simple. What can we do? That just like there is the conversion of velocity into angular velocity, displacement, and so on and on, just convert the mass into the moment of inertia. That's it. M into I. So what is that helping in? Have a look. All the formulas which you have made till now will be very easy. First of all, so displacement, velocity, acceleration, mass, force, then momentum, work, and then power, and then time. All will be converted into rotational form like this. So it's very easy, because work and power are scalar quantities, as well as time is a scalar quantity. You will not convert them. They will remain as they are. But all the other things become very easy. Have a look how. What is the formula for the value of force? So force is equals to mass into acceleration. But can I make another formula for the version of rotation? It will be equals to I into alpha. Rotational version of mass, moment of inertia. Rotational version of acceleration, angular acceleration. Very simple. So every place where you actually see the value of mass, you have to simply remove the mass and you have to put the acceleration. So, oh, sorry, you remove the mass and you have to put moment of inertia. That's it. Now the whole thing comes down to this, that how can we actually calculate moment of inertia? Now, there are multiple ways to calculate it, but we will start it from the point masses. Point masses means, imagine you have some point masses like this. So this is the axis of rotation. From here, the body will rotate, and you have a body kind of over here, M. This is a point mass, which is at a distance of R from the axis of rotation. Of course, perpendicular distance. So if you want to calculate moment of inertia, the formula is multiply the mass with the R square and you will get it. That is, if you have a lot of them, imagine like this. This is the axis of rotation, mass 1, mass 2, mass 3, and all of them. And if you want to calculate the overall moment of inertia, it will be M1R1 square, M2R2 square, M3R3 square, and so on. And that's it. So we can actually have a look onto this question. Like if this is the axis of rotation, yep, then there are mass 1, mass 2, and mass 3 at some distances from the axis of rotation. So if you will calculate it, you will clearly see that mass 1 is actually at a distance of 0 from the axis of rotation. So M1 into 0 square. Mass 2 is at a perpendicular distance of a by 2 from the axis of rotation. So M2 into a by 2 whole square. And finally, M3 is at a distance of a by 2 again. But this is a very easy question and you will not receive a question like this. This was just to show you that what is moment of inertia and how to calculate. The actual calculations and actual meaning of moment of inertia will be like we will do it in the next class. Yeah. This was just for point masses, not for distributive masses like linear mass or areal mass or volumetric mass. It's not for that. But for point mass, this is more than enough. And all the conversions we have done, specifically, you can say this whole thing over here sums up today's class. That how are we understanding all the other things in the terms of rotation, basically converting the linear form into the rotation form. That's it. So that's it for today. We'll meet again in the next class. Till then, bye-bye. Thank you so much. Bye.